All right, well, hello, Honors Algebra 2. If you are watching this video, then I want to say, first off, kudos to you. I think that this is some important stuff, and I think that it's stuff that's going to benefit you later on in your future classes. So while the rest of your classmates are struggling just to kind of understand the basics of what's going on, here you are, and you're going to already know everything that you need to know, and that's going to be a good feeling. So kudos to you. That being said, I'm going to try not to go too quickly through this, but I don't want to take too much of your time since this obviously won't be on the quiz this week. So I probably will skip over some details, and if there's any questions, please feel free to reach out and ask me either during office hours or email. So let's get into things. First off, we're going to look at the graph of cosecant. As a reminder, cosecant is the reciprocal for sine. So really what you want to think about as you're filling in this table is taking 1 divided by each of the numbers or taking the reciprocal of them. The first one, 1 over 0 is undefined. That's going to be one of our, actually you can probably guess it, that's going to be one of our asymptotes that we're going to look at. At pi over 6, 2 over 1 would be 2, and I'm not going to bother rationalizing just to make things go a little bit more smoothly. So 2 over radical 2 and 2 over radical 3, I'll leave that. For 1, reciprocal of 1 is just 1. And then we start to repeat actually 2 over radical 3, 2 over radical 2, 2 over 1 would be 2, and again we get to 1 over 0, which would be undefined. Really the only thing that's going to make the second half different is that it's just going to have negatives in front. So negative 2, negative 2 over square root of 2, negative 2 over square root of 3, negative 1, and then we're going to have negative 2 square root of 3 again, negative 2 over square root of 2 again, negative 2, and then back to an undefined asymptote. Okay, so similar to something we've done in other sections of this, we're going to kind of focus on these whole number values or important values. You're actually going to notice something kind of unique about cosecant that we hadn't seen, which is that it's actually never going to get to a y value of 0. And that'll be something we'll talk about when we talk about the range. But just to give you an idea of what this graph looks like, let's go ahead and fill in the asymptotes first. So at 0, at pi, and at 2 pi, we have asymptotes. And then in pi over 6, comma 2, we're going to have a point there. Pi over 2, comma 1. In fact, let's do this just to make it look a little bit nicer. Let's go 1 here, 2, negative 1, negative 2. That way it's just a little bit more spread out from when we're graphing it. So pi over 2, we're at 1. At 5 pi over 6, we are at, let's see, 2. And then we're going to be at negative 2 for 7 pi over 6. We're going to be at negative 1 for 3 pi over 2. And at 11 pi over 6, we're at negative 2. And so, obviously, we're not graphing the in-between points, so you'll just kind of take my word for it or graph it on your own. What it actually ends up looking like, let me draw it a little bit better, is it actually ends up looking like kind of a set of parabolas almost, is a good comparison for these. But they look something kind of like this. So, let's kind of talk about some of the key features of this. The domain is going to be all real numbers except for those asymptotes, which if you notice the pattern, 0, pi, 2 pi, so we're talking about 0, if you go negative, plus and minus pi, plus and minus 2 pi, and so on. So all the kind of the whole number values for pi are going to be our exceptions. Those are where the asymptotes are. So that would be a good thing to include down here. So 0, plus and minus pi, plus and minus 2 pi, and so on. For the range, I don't write that with inequalities. Notice that you can have values that are less than negative 1, so less than or equal to negative 1. You can also have y values that are greater than or equal to positive 1. But you can't have anything in between negative 1 and positive 1. So kind of an interesting way that works out. What you're also going to notice is that you're going to end up with some relative minimums and relative maximums. The relative minimums are actually going to be where the relative maximums are for your sine graph, and vice versa. The relative maximums are going to be the same as the relative minimums for your sine curve from before. So those kind of just get switched. Okay, so that's kind of your crash course in cosecant. Let's do the same thing with secant. So if you recall, secant is the reciprocal for cosine. So again, if you've not had a chance to fill in those values for cosine, this would be a good chance to pause the video. We'll also be doing the ones for tangent. So if you've not already copied those in from previous sections, why don't you go and do that real quick and then come back to the video, and that way you can be able to kind of keep up with where I'm going with this. Okay, so similar to what we did before, I'm not going to rationalize as I fill these in. So the ones that are like 2 over radical 3 and 2 over radical 2, we're just going to leave. Obviously, if it's 2 over 1, we're going to simplify that. And if it's 1 over 0, that's obviously going to be undefined. So then negative 2 over square root 2, 2 over square root 3, negative 1, and so on. Again, undefined when we get to 1 over 0, 2. Okay, I think we've gone through and found reciprocal for all of those. So reciprocal, you're just flipping the fraction. And again, we're not bothering with rationalizing because really we're not going to use any of the ones that we'd have to rationalize anyways. We're going to kind of focus on these values that are either whole number or asymptotes to kind of help us get just a basic idea of what this graph looks like. Similar to what we did with cosecant, let's just count by 1 and 2 as so on our graph. So each grid line will be a half a value. Okay, so our first point that we're on our graph is going to be 0, 1, and then we're going to have at pi over 3 a value of 2, so that'll be right here. At pi over 2, we're going to have an asymptote. And then at 2 pi over 3, we're going to be down here at negative 2. At pi, we're going to be at negative 1. At 4 pi over 3, we're going to be back to negative 2. And at 3 pi over 2, we're going to be undefined, so an asymptote. And then we're going to be at 2 and 1 respectively here. And so you can see it's going to be kind of a similar graph. It just got kind of cut apart a little bit differently if you want to think about it that way. So you still have these kind of parabolas that are shaped that we're looking at here. Obviously, if you continue to the left and right, you'd be able to see the ones that are opening up as well. But just with the way the graph worked out, that's kind of the way it looks. So let's go through key features. So again, domain is going to be still all real numbers, except for where your asymptotes are. And so asymptotes, let's maybe list those first. Those are going to be at pi over 2, so plus and minus pi over 2, plus and minus 3 pi over 2, plus and minus 5 pi over 2, and so on. And so what I'll just say for domain is all real numbers except for kind of what your asymptotes are here. Notice the range actually, though, is going to be the same. So y can be less than or equal to negative 1. It can also be greater than or equal to positive 1. And then relative maximums are going to behave the same as they did for our secant graph, or cosecant graph, which is that your relative minimums were the relative maximums for our cosine curve, and the relative minimums or maximums come from the relative minimums for your cosine curve as well. Okay. Lastly, let's talk about tangent. So again, if you've not already had a chance, go ahead and copy those values down real quick, and that way we can talk about this graph. Okay, and so then going through and finding reciprocal for all of these, we are undefined at 0, 3 over square root 3, 1, we've got 1 over radical 3, and then actually where it was undefined, think about what was happening there. That would have been where the reciprocal actually would end up being 0. So that's kind of the tricky part with the undefined on cotangent, is that when you take 1 divided by something that was originally undefined, that actually ends up making the reciprocal 0. So just be careful with those. And then filling in the rest of these here, go ahead and do that real quick. Undefined, 3 over radical 3, 1 over radical 3. Again, when you get to undefined values, those become 0. Almost there. And undefined. Okay, cool. And again, similar to what we've done with our previous ones, let's focus on the values that are whole values or asymptotes. So I'm looking at these values right in here. And so with those values, maybe let's just do the asymptotes first. We've got an asymptote at 0. We've got another asymptote at pi. And then another asymptote at 2 pi. So really, if you want to think about it, your domain is going to be kind of all real numbers except for where your asymptotes are. So again, I'm just going to kind of draw that arrow down there. And then let's take a look at what this looks like. So at pi over 4, you're at positive 1. Again, let's kind of use the same counting that we've done in the previous problems. So we'll put 1 there. At pi over 2, you're at 0. And at 3 pi over 4, you're at negative 1. And then again, when you get past that first asymptote, we're at positive 1 for 5 pi over 4. 3 pi over 2, we're at 0. And 7 pi over 4, we're at negative 1. So again, you'll kind of have to take my word for it. If you want to test it out on your own later, you're more than welcome to type in those values. You actually end up getting a graph of cotangent, which looks very similar to tangent. And all it is it's almost like a reflection. It's kind of been reflected. The asymptotes have been moved a little bit, but a lot of it still works kind of the same. For range, that means that negative to positive infinity or all real numbers would be acceptable as to write that. The formula for asymptotes is that you take pi divided by the absolute value of b. Your x-intercepts end up being at pi over 2, 3 pi over 2, 5 pi over 2, and so on. And your period is going to be the same as tangent. Take pi divided by the absolute value of b. So to summarize kind of what we've seen in this section, our steps to graphing cosecant, secant, or cotangent. The first thing you're going to want to do is actually graph the reciprocal function first. So remember that the reciprocal of, let's start with cosecant, is 1 over sine. The reciprocal of secant is 1 over cosine. And reciprocal of cotangent is 1 over the tangent. So whichever one you want to graph, cosecant, secant, or cotangent, start by graphing the reciprocal. So start by graphing sine, cosine, or tangent first. The next thing is to graph the asymptotes of your function. So the asymptotes for cotangent are wherever tangent would have been equal to 0. For cosecant, that's wherever your sine values would have been equal to 0. And for secant, that would have been wherever your cosine values are equal to 0. And then step 3, it depends on which type of graph you are making. For a cotangent is what it should have said, so let me add in the co part. But for cotangent, I reflect all of the y values, and that'll get you your graph of cotangent. For secant or cosecant, you just use your relative maximums or minimums, and you graph the remainder of your function, understanding that they become opposites. So I do want to give you one example of kind of what this looks like. That way we can kind of see how this would work. So for this example, it's asking us to graph our function of 2 secant of x. So first thing we're going to do is we're going to graph a different function. We're going to graph g of x equals 2 multiplied by cosine of x. And that's because cosine is the reciprocal of secant. So to graph what that looks like, and again, let's kind of count this way. So going, and we won't get down to 2 and negative 2, but we'll put those on there anyways. So graphing cosine, you would start at 0, 1, go down to pi over 2, down to pi, back up at 3 pi over 2, and back up at 2 pi. So I'm going to put this kind of in dashed lines. This is not our actual graph. This is just kind of our base for what we'll have for our graph of secant. Okay, so that's step 1, graph your original curve. Step number 2, and actually, well, I guess before we get too much further, I did actually make a mistake here, so let's get that fixed. And maybe you caught it as I was going through it here. But I actually do need to go up to 2 and down to negative 2 because our amplitude, I wasn't looking closely enough, is actually 2. So let me get those in there real quick. And what that's going to do is stretch our graph to look something kind of like this. So if you caught that, nice job. If not, you need to be on me a little bit more carefully. All right. So next thing to graph is going to be our asymptotes. So what we're going to do is we're going to put asymptotes anywhere our graph would have been at 0. So there's going to be two asymptotes. One is going to be at pi over 2. One of them is going to be at 3 pi over 2. And then from there, what you'll do to create the rest of your graph is you're going to use your relative maximums to make the minimums and relative minimums to make the maximums. So for this relative maximum here, that's going to become a relative minimum. And vice versa here, relative minimum becomes relative maximum now. And relative maximum becomes relative minimum. And then once you're done, if you wanted to erase kind of part of your original curve, you could, to make it a little bit more clear what your actual graph was. So then there would be your graph. Obviously, you hopefully would have a little bit more space to draw a little bit more carefully, but not too bad of a sketch for just getting the basic idea. All right, that's it for Unit 10, guys. That's it as far as stuff that you absolutely need to know going into next year. Unit 11 is still going to happen. I think Unit 11 is going to be a really good unit. So hopefully you'll be able to take the time to go through some of those lessons as well. Just don't forget that we've got a quiz this Friday on Unit 10. It's only going to cover 10.1 through 10.3, so this section won't be on it. But it is a great section for you to have and understand going into next year. So that being said, guys, have a good rest of your time, and I will talk to you next time.